Good day, everyone. So in this video, we're going to discuss about um, how to solve a problem in dual cycle. So here's a problem example. In a dual combustion cycle, the compression starts from 1 bar and 20 degrees Celsius. The compression ratio is 18 and the cutoff ratio is 1.15. The maximum cycle pressure it should be temperature, is 1360 Kelvin. The total heat input is 1 kilojoules per cycle. Calculate the following: the thermal efficiency of the cycle, the network output per cycle, and also check that if the efficiency does not contravene with the Carnot principle. So we have, for the solution, we have the known data, which is the initial temperature, the 20. We add 273 to convert it into Kelvin, and then the hottest temperature, which is 1360 Kelvin. And then we have the cutoff ratio of 1.15, and then the compression ratio of 18, and then the constant of 1.4. So solving for T2, we just we just use the formula for the isentropic PV and T relationship. So RV is the compression ratio. So T2 is equals to T1 times the compression ratio raised to the constant minus 1. So we get 931 Kelvin. So solving for T3, we have the constant pressure. So we have T3 is equals to V3 over V4, which is the cutoff ratio. Then we can just cancel out, and then we can make it into the cutoff ratio. And then T4 divided by the cutoff ratio is equals to 1360 divided by 1.15. And then you have the answer for T3, which is 1183 Kelvin. So we have also the pressure ratio, which is K, which is equals to T3 over T2. So solving for the efficiency, we have 1 minus K, which is, or the pressure difference, or the pressure ratio, times the cutoff ratio raised to the constant minus 1, divided by K minus 1 plus the constant times the pressure ratio times the cutoff ratio minus 1 multiplied by the compression ratio raised to constant minus 1. So um, let's just input the data we have solved, or the data given, and we can get the 0.68 efficiency. So now solving for the work net, we have the efficiency times the input, the heat added. So we have 0.68, which is the efficiency we solved, and then times 1. So the 1 is given, 1 kilojoules per kilogram per cycle. 1 kilojoules per cycle. I'm sorry. So we have 0.68 kilojoules per cycle. So for the Carnot efficiency should be higher. So the efficiency is equals to 1 minus T hot minus T cold, and then 1 minus the cold temperature, which is 293, divided by the hottest temperature, which is 1360. We have the Carnot efficiency of 0.785. And since the figure of 768 is lower than the Carnot principle, so is lower than the Carnot efficiency, so that the Carnot principle has not been contravened. So we already solved the work net, which is 0.68, the efficiency of 0.68, and then we also learned that the Carnot principle has not been contravened since the efficiency is less than the Carnot efficiency. So that's it for this video. Goodbye.